Okay, should be recording now. Going to do a series of Smart Alex tasks to help facilitate learning here. I was asked to do chapters 9, number 4, chapter 11, 1 through 5, chapter 20, number 7, and chapter 18, number 2. I'll tackle chapters 9 and 20 right now because those are comparable. Chapter 11, Smart Alex tasks, you're not going to have to do. I'm going to take those down just because the process tool is giving folks some difficulty. And then chapter 18 I'll do in a separate video because it's a little bit more involved. So first, chapter 9, number 4, the fashion student was interested in factors that predict the salaries of catwalk models. She collected data from 231 models. For each model, she asked them their salary per day. Okay, so we need the supermodel data for that one. So we're going to go to the shared Dropbox folder, and we go to field data sets, and we're going to open up supermodel data. Okay, and the question asks us, can you conduct a multiple regression model to see which variables predict a model's salary, and then how valid is the regression model? So these are our variables here in our data set. We have information on their salary, that's per day, I take it. And then we have their age, we have the number of years, it looks like, that they've worked as a model, and then their beauty on some arbitrary score. A panel of experts from modeling agencies to rate the attractiveness of each model as a percentage with 100%. Oh, okay, so if you're 100 on this, you are perfectly beautiful, I guess. Okay, so this one's a 78%, whatever. So we're going to try and predict your salary from your age, how many years you've been modeling, and your beauty score. Okay, and so we're just going to dump those in a regression model. But the important thing is they're wanting us to assess how valid the model is. Okay, so we'll make sure we do that with the options. We're going to go to analyze, we're going to go to regression, we're going to go to linear. Our dependent model, of course, or dependent variable, I should say, is going to be salary, and we are going to be predicting salary from their age and their beauty. So I'm just going to highlight all of those. That's the regression model, but we want to make sure the model is valid. So we can assess that with a couple of statistics that are covered in detail in your textbook, and I'm not going to cover them with you right now. But collinearity diagnostics, we'll check that one. That will allow us to assess for multi-collinearity. Okay. And we'll do case-wise diagnostics to look for outliers. Okay, we'll just leave it at 3 standard deviations above the mean. Continue. And you know, your textbook might, I think I've told you about some other tools you could use to test for homoscedasticity and heteroscedasticity. And you can check those with a residual plot. So you could put the predicted residuals on the X and the residual, observed residuals on the Y. You could even have a histogram with a normal probability plot if you want. Okay, so we'll just hit OK, and let's see what we get. Okay, so the very first thing, we get an R, which is the correlation for the entire model. We get the R square, so 18% of the variance in salary is explained by this model, so not a lot. The overall analysis of variance is significant, so it tells us our model is better at predicting salary than no model at all. Not really a useful table to us, though. We care about this one. This is the actual regression table. This is the one you'll want to include in your homework output. So this tells us that as age increases, salary increases by 6, I'm guessing, dollars per day. So for every year you're older you are, you earn $6 more per day, if I'm interpreting the outcome variable correct. the number of years that you've served as a model or you worked as a model is negatively associated with salary. That doesn't seem to make sense. In fact, for every year that you've worked as a model, we would expect you to earn $5 less. And then your attractiveness is negatively associated with the money you make per day. And that doesn't make sense. The important thing to point out is that the age and the number of years variables are statistically significant. The attractiveness one is not. As you can see here, it's greater than our conventional threshold of 0.05. The important thing to point out, though, is that the second part of the question is how valid is the regression model? Well, we can start to see here that there are some serious problems with our model. This right here, the VIF, is something you're going to want to pay attention to. This VIF statistic stands for variation inflation factor, or variation index factor. I'm pretty sure it's variation inflection or variance. Yeah, I forget. Now you got me all tongue-tied. It's been a while. Inflation factor. I don't know. Look it up. But the VIF you want down by 1. You don't want a VIF statistic over 10. 1 is optimal. This is good, but this is really bad. This tells us that basically these two variables are measuring the exact same thing, and we call that multicollinearity. So evidence suggests that the model suffers from multicollinearity. And if you think about it, that's kind of obvious. I think the author here set us up. Obviously, the older you are would be highly correlated with the number of years that you've worked as a model, right? And you can see that if you were just gonna, I don't know, do a scatter plot between the two. I'm sure there's a positive association between your years, your age, and the years you've served as a model. Yeah, see here? This is your age. As it increases, the number of years you've served as you've worked as a model, not served. I guess they're not public servants. I don't know why I keep on saying served. Worked as a model. That's a very, very, very strong correlation, right? And if you wanted to get the statistic for that one, you could go to correlate bivariate. You want age correlated with years. Probably 8 something. Oh, yeah, 0.95. That's almost a perfect correlation. So there's multicollinearity here. That's the problem. So let's run the regression again. I'm going to do it all again. All the other options that I did before, they're still saved, right? So I'll do it again. So you can see here that the model is not valid, okay? There is multicollinearity going on here. You can see here in the case-wise diagnostics, there are some really high residual values. You want these under 2. If they're over 3, it's kind of concerning. There's a couple that are over 4. That means they're 4 standard deviations above the mean residual. And that's a little alarming. That tells us that there are outliers, some really influential cases. And you can test the influential cases. I'm not going to do it for you now by saving Cook's statistics. If you're going to do the regression again, you could go to statistics, save, and you can get Mahalanobis distances and Cook's values. You could even get leverage values, and that'll tell you. And then if you run the model, you'll go back to your data, and you'll see you have 3 new variables. You have Mahalanobis distances, Cook's values, and leverage statistics. And if you sort descending, you can see the highest Cook's value is 0.22. Mahalanobis is up there. You need to calculate the statistical significance for these, and the textbook tells you how to do that. But that gives you an idea about outliers. But you can already kind of see that there are some outliers. And that's what this tells us also. This is the residual, standardized residual. And you can see that there are some residuals that are way out here. And this is a little alarming. This tells us that the model is not predicting salary very well. This is the predicted and observed residual plot. And you can see, because you want this plot to look like no pattern at all. You want all the dots to just be randomly drawn throughout, but that's not what we're seeing. We're seeing that there are much smaller residual values at lower values of the predicted value. And then as they get bigger, the variance really like explodes at higher predicted values. So in short, the model is pretty bad. The way you solve it is to take out one of those variables that are collinear. So, we detected from the VIF that it's age in years. You might want to take out age or years, whichever one you have a theoretical reason for leaving out. I'm kind of curious about your age. Do younger women, I'm assuming these are women, younger women get paid more? I don't know, we can find out. But you can see now if I take out that other variable, things start to make a lot more sense. My VIF values are where they're supposed to be. You can see as age goes up, your salary goes up, and that's significant. Your attractiveness has nothing to do with your salary, which is pretty interesting. You still have some outliers. Okay, you can see here that I didn't take care of the outlier situation. Dealing with outliers is much, much trickier thing to do. Your textbook talks about some of the things you might want to consider. There's not really a right or wrong answer there. It's a bit of an art. Do you take out the high value, the outliers, or do you keep them in? It's really a difficult decision to make. But talk about that in your response. Okay, that's chapter 9, number 4. Chapter 20, number 7 is really similar. So let's do that one. It's about condom use, and we're trying to figure out the variables that predict condom use. Okay, so we need the condom data for this one. So I'm going to go back to the data files that I've uploaded for you, and we're going to look up condom. Here we go. And we're trying to predict whether or not someone used a condom. Okay, and you can see our outcome variable is 0 and 1. Did you or did you not use a condom? Therefore, we have to use logistic regression. And the question tells you to, let's see, put in variables in a particular order, right? The outcome measure, the predictor variables were scales from the condom attitude scale, gender, safety. Okay, so previous research has shown that gender, safety, and risk predict condom use. And then carry out an analysis to verify these findings and test whether self-control, previous usage, and sexual experience predict condom use. Oh, but that's not the one you asked for, right? You asked for the question about how reliable is that model. Okay, so that's the one we'll do then. So we'll skip the model building and just go to the final model. So we'll go to, we're going to go to regression again. We're going to go binary logistic. We're going to go to condom use as our dependent variable, and we'll throw in all of the predictors here at this last model, okay? The question before, number 6, asks you to build the model in steps, right? Like I think you're supposed to put in, the first time around, you're supposed to put in gender, and then you're supposed to put in safety, and then you're supposed to put in risk, perceived risk. And then the next model, you're going to add self-control, self-con, usage, previous usage, and sexual experience. Now, the interesting thing is that previous usage, as you can see, is categorical. So you need to tell it that you want the categorical variable to, to do contrasts for all the different levels, or else you're not going to be able to make sense of the coefficient. And then you were to hit continue. Oh, before you do that, you want to see if the model gets better. So you're going to want to go to options. Let's see, do we have, where's R squared change? Let's see. Okay, let's see. No, oh, you can get Cook's distances and stuff again for outliers. Let's maybe do that. Option, classification correlation. Oh, let's do a case-wise listing of residuals. Okay. So let's do that. Okay, so here we go. You'll go through your first model, and you can see here you get the chi-square, and you also get your R-square values right here, Cox, and I never know how to pronounce that. Nagelkirk? Not really sure. But you can essentially interpret these two as R-squared values. So 26% of the variance, 35, 36% of the variance. But that's the first model, but then this is the second model where we added everything, right? And you can see here that these are higher values. So it does appear as if, what was it? Self-control, previous usage, and sexual experience predict above and beyond. Is that what the question was? Test whether verify by and test whether self-control, previous usage, and sexual experience predict condom use. So sexual experience does not predict condom use, not significant. Previous use does, whatever this first value was. I didn't see how this was coded. So that one does, barely though, look at that, barely. Relationship safety does predict condom use. And perceived risk is associated with condom use, and self-control is also as well. These are significant values. You can see relationship safety by looking at the odds ratio here. As relationship safety increases, because this is less than 1, we would say that your odds of using a condom decrease. So that makes sense. If you feel safe, you're going to be less likely to use a condom. If you think it's risky, that's going to increase your risk. Okay, this is above 1, so your odds of using a condom, if you perceive risk, are 2.5 times that of people that don't perceive risk. Self-control, if you have higher self-control, you have greater odds of using a condom, etc. Okay, the thing we're interested though is for the next question is how reliable is the model? Well, it's the same process as before, where you're going to look at influential cases here. You can see I'm looking at the residual values. You have just really one alarming value. So this is because it's over 3 standard deviation. So it doesn't look like there's any really influential cases here. Now we need to test for multicollinearity like we did before, but you don't really get VIF statistics in a logistic regression model. So you can just do the whole thing as a regression model, just a linear regression. So if you go to regression and you were to go to linear, condom use, and then just dump everything in there. And then if you were to go to collinearity diagnostics, continue, you'll get those great VIF statistics. And look, they're all around 1, so there's no multicollinearity going on there. So I would say overall, this is a pretty reliable model, although I'm doing this pretty quick and dirty. The textbook gives you a bunch of other things you should be looking at, right? But hopefully this helps. That's chapter 9 and chapter 20. Chapter 11, you do not have to do questions 1 through 5. Just forget about those. If you have already done them, you can submit them for extra credit. Otherwise, just feel free to ignore them. And then I'll record a video on chapter 18, number 2 right now.